In this video, we will show the functionality of how a hydraulic braking system works in automotive applications. We'll identify each of the components and their role in the entire system, combining them together to make the vehicle stop. A modern brake system is actually a very simple hydraulic circuit. It uses high pressure to force a fluid through a confined space to push a piston, which in turn actuates mechanically and clamps or grips a rotating metal surface, thus stopping the vehicle. It all starts at the master cylinder. The master cylinder has three purposes within the braking system. It stores the additional fluid needed to keep the system intact when the brake pedal is applied and moving the pistons at each wheel. It generates the necessary pressure to make those pistons move sufficiently to slow down and stop the vehicle. It is the adjustable switch which allows the driver of the vehicle to have control as to how quickly or how slowly the vehicle slows down and stops. From the master cylinder, we move into what is called the proportioning valve. This valve is designed to take the fluid under pressure from the master cylinder and distribute it in a predetermined percentage to each end of the vehicle. In most cars on the road today, the front brakes do between 80 and 85% of the braking. The rear brakes apply the remaining pressure needed to slow down and stop the vehicle. This is necessary because of the weight distribution of the vehicle itself. The front of the vehicle is much heavier than the rear, and there is a possibility of the vehicle skidding sideways if the rear brakes engage too quickly or with too much force. From the proportioning valve, there are steel fluid feed lines that run to the front and rear axles of the vehicle. It is absolutely imperative that all of these lines have no leaks in them at the connection points or in the lines themselves. If this happens, then you will have a brake and in some cases an AGS light illuminated on the dashboard. In the front, these steel feed lines are connected to brake hoses, which are connected to the front brake calipers. The fluid pushes out a single large or smaller multiple pistons, which push against a steel plate embedded with brake friction material on it, and this causes a clamping movement on both inside and outside braking surfaces of the front brake rotors. Steel feed lines run from the divider block and run across the axle in both directions and end at the wheel cylinders. These each have two opposing pistons, which when pressurized, force the rear brake shoes friction material against the inside surface of the rear brake drums. If the vehicle is equipped with rear disc brakes, then it's set up almost identically to the front in that there are separate hoses and rear calipers. So basically, when you push your brake pedal down, it pushes the fluid, which pushes the pistons, which push the friction material into the rotors and drums, which push the vehicle to a stop. The harder you push, the more pressure it generates, making the rest of the system work harder and grip harder, causing the vehicle to slow down harder.